Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher, Ron Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You are always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 10 until 11 in the morning. And we are now in our 9th and final week of our course. Today is our last session together. So at this point, you definitely should be submitting work for marking as we are wrapping up. But a reminder that the support questions, the ones with the little pencil icon, are not for marking. You decide which ones and how many of these to do. If you understand a concept, feel free to skip questions. You don't have to do them all just because they're there. It's a good idea to do some of them though. And then also check your work. The answers are in the back of the book for the support questions. So you can check your work and make sure you're on the right track. The key questions are the ones with a little key icon. And these are the ones to submit for marking. So these you need to do all of the questions so that I can mark all the questions. And you need to show your work so that I can truly understand what it is that you understand. And if you're struggling with something, this gives me more information so that I can help you to improve and figure out those concepts. So how do you submit your work for marking? Well, there's 3 methods. The first is to scan your work and send it in electronically. If you have a device, like a smart device, you can scan your work using that device. Apple ones have the Notes app and Android devices have a Google Drive app. These are free apps that come generally with these devices and are pretty straightforward to use. However, if you do need some help figuring it out, on my YouTube channel, there are tech tutorials that walk you through step-by-step how to use these different apps and just are fairly straightforward. If you need more help, feel free to ask. I'm happy to support you however I can. Then once you have an electronic file, you can send it to me through email to studentwork@nnec.on.ca and then CC it to me directly to Bronwyn Slate at nnec.on.ca. Or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We are the bright red building next to the post office and have a small white mailbox next to our side entrance. So you can just put your work in there at any time and we'll get it back to you as soon as we can. The third method is to hand your work into your DEC. Your DEC can either send your work in through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students can also send their work in by fax if that's something you have access to and is easy for you. Just give us a heads up that it's coming because sometimes things get lost in the shuffle. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. All of our radio Zoom classes are recorded and I've shared them to YouTube shortly after broadcasting. I put them in a playlist called MBF3C, which is our course code. So it's really easy to find. And then I also share them on Facebook so that you still get the full experience. And that's really easy to find. Also on my YouTube channel, there are short videos that explain confusing concepts and common errors that I know students make. So this is a good place to go check out if you are struggling with something or keep making the same mistake. There might be something there that walks you through that's like a 2-minute or 10-minute video that can really just help you figure out that one concept. Math is a really, really visual subject, so I strongly encourage you to access the videos. Just listening to me on the radio is only going to give you a very small portion of what it is that we are learning about. So the videos are your friend. If you can't join me through Zoom or watch the YouTube videos, you don't have reliable internet or something like that, let me know and I'm happy to send you a copy of the videos so that you still get the full experience. So if you have any questions or concerns, please reach out and connect with me. You can email me at bronwyn.slate@nnec.owen.ca. Connect with me through Facebook at bslate Wahsa. Call me at the office at 807-737-1488. My extension is 2209. You can also call us toll free at 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m. So just reach out to me and I will get back to you as soon as possible if for some reason you don't get me directly. Today is our last day of review and our last day of our course. So we are reviewing Unit 4. In our previous sessions, we've done a day on Unit 1, a day on Unit 2, a day on Unit 3. So now we are looking at Unit 4, which is covering lessons 16 through 20. But first, let's activate our brain with some mental math to get ourselves awake. As you know, I don't believe in Mad Math Minutes. They focus on speed and memorization, which I don't believe are the most effective and useful tools in math learning. So instead, we work on developing strategies that are based on our own comfort with numbers and concepts so that we can build a toolbox of things that work for us. Today's question is 144 divided by 6, and we're going to use the strategy of shared groups. So with shared groups, usually when we're learning division, we're dividing by 6, so we're going to make 6 groups. And then we go through and put one thing in per group. Now, 144 things is a lot of things. And if we have to go through and put one little tick in each of these groups, that's going to take forever. So I suggest that we share in groups. So I think that I'm going to start and put in 10 in each. So instead of writing 10 little ticks, I'm going to put in the number 10. So if I put in 10 in each of my groups, I have 10, 20, 30, 40, 50, 60. Okay, I still have more things to go. So I'm going to see if I can do another 10. So 60, 70, 80, 90, 100, 110, 120. Okay, so now I've done 120. I shared those things and I'm going up to 144. So I don't think I can't do another 10. I can't even do another group of 5, I don't think. Let's try 2. So I'm at 120. So 122, 124, 126, 128, 130, 132. I'm going to keep going with 2. 134, 136, 138, 140, 142, 144. So I can see I've shared out 144 things. That was so much faster and organized than doing it out by just little ticks and hoping for the best and not getting confused, which most of us probably would at some point. So then in each group, how many is there? Well, in each group, there's 10, 20, 22, 24, 24. So 144 divided by 6 is 24. And that's how using sharing groups opposed to just individual ones can really help move into more fluent division. All right, before we go into our actual review of our different lessons, I want to remind you what to expect for your final assessment, because it is different than probably what you're expecting. It is not an exam. It is a culminating assignment. It is a project that takes a chunk of time to do, but it covers all of your 20 lessons. So you need to do all the 20 lessons first. This is going to set you up for the most success to do the assignment. It is open book. You have access to your assignments, to the YouTube videos, to your IL booklet, to Desmos, to virtual manipulatives, to everything that we've used. You can use it all. It is not timed, but it does have a deadline. I'm going to give you probably 2 to 3 weeks. We'll discuss that when you're ready to do it. So you do need to have all of your work done first and then still have a chunk of time to complete it, as again, it's going to take you some time. It's not a quick thing. It is a bigger project that is going to stretch your brain. The structure is likely going to be unfamiliar. It is going to be unfamiliar. It is not just you answering questions that I provide you in a booklet, it is something that is going to stretch your brain and probably be outside of your comfort zone a little bit, but it really is going to showcase what it is that you understand. Okay, so let's review our last 5 lessons. Lesson 16 is sampling data. So with this, we started with making sure we understood our statistical vocabulary, so we knew what population and sample meant. And then we looked at types of sampling. So we looked at simple random sampling, systematic sampling, cluster sampling, stratified, convenience, and self-selected or voluntary sampling. So these are all different ways to choose people to ask questions to get information about a whole population. Remember, a sample is a small part of a population of a group of people that hopefully represents that group of people. And these are different methods of figuring out how to pick those people. Some of them are better than others in different situations. We went through the pros and cons of each of these. They all have things that make them great, and they all have things that make them potentially biased and not great. So you really need to pick and choose what makes the most sense for you if you're collecting data. All right, so for practice question number 1, determine the best sampling method for each survey. So school newspaper wants to determine which presidential candidate in the upcoming student council election is supported by the majority of students. So this, again, with these things, there isn't necessarily one particular answer that is perfect. Some of them, there's one that's more obviously better than others. These ones, it's about being able to justify why you pick that option. So we have no information about the student body. We know that it is it's a school, and we want to ask a bunch of the students some information. So I would say that even just simple random sampling would be potentially fine. You might have a justification for something else, but a simple random sample is going to get a bunch of different answers across the population. And we don't know anything else about the population to just stratify it or cluster it. So that could work. Part B, a light bulb manufacturer wants to determine the lifespan of a certain type of light bulbs in hours. So I would say probably a systematic system. So like picking every 50th light bulb or something and testing it is probably a good way to make sure you're testing your entire product and not just being like, okay, the ones that we created at the beginning are like this, but the ones that we created at the end, we don't know. So doing something throughout the whole was probably a good idea. Part C, the Parent-Teacher Association wants to determine the average number of hours per week that students spend on homework. So with this one, I would say probably knowing the difference between like having it like grade 9 students might be different than grade 12 students. So I would say probably I'm trying to think which one is that I want. A stratified sample. So getting information from the population according to different grades is probably going to give you more information. So grades would be your strata. And so then being like getting answers about from the proportion of grade 9s versus grade 10s versus grade 11s versus grade 12s. Part D, the producers of Rock Idol want to determine which of the 2 remaining candidates should be the next Rock Idol. This, I would say, is voluntary. So only the people who watch this show or listen to this radio or whatever and care are probably going to be the ones who are going to answer. You don't need to sample the whole population because probably a lot of people don't necessarily care. All right, lesson 17, measures of central tendency and standard deviation. This is something that we did 2 lessons on. The first one, we looked at the central tendency. So mean, which is when we add up all of our data points and we divide by the number of data points. Median, which is when we order our data points from lowest to highest, we find the middle value. And then if we have the 2 middle values, because it's an even number of data points, then we add those 2 up and divide by 2 to find the halfway point between them. And then the mode is when we find the most frequent value. It is possible to have more than one mode. If you have more than one value data point that has the same number of frequencies. Also, sometimes data has not necessarily 2 equal modes, but it has your data is clustered around 2 higher frequencies. Then we look at standard deviation and measures of variability. So first we looked at range, which is the difference between the lowest and the highest values of your data points. This is really easily distorted by having outliers. So if you have a really high highest value or a really low lowest value and everything else is clustered around a different space, then this is going to really not tell you a lot about your information about your data, because your information is skewed based on those extremes. Then we looked at variance, which measures how far data points are spread out in a set of data compared to the mean. This is a bit confusing, the variance. It's squared units, so it means that the number that you get is hard to compare to any of your other data because it's squared compared to the units of the data that you're looking at. So that I'm sure, again, that this variance is useful somewhere in terms of statistical measurement. It's not something that I've ever found useful, except to figure out your standard deviation. So to find your variance, you need to sum of the squares of your data points, distance from the mean, divided by the number of data points minus 1. So it's a bit awkward. It's a bunch of work to do, but it means that it sets us up for a standard deviation, which is the typical amount that the data points differ from the mean. And this is in the same units as your original data because it's the square root of your variance. So I only generally use the variance to find the standard deviation. Again, I'm sure the variance is something that makes sense in other places in the world in terms of different, like using statistics, just not something that I use very frequently or makes a lot of sense to me. Okay, so let's do some practice questions and find out let's play with some data. So we have a data set, which is this list: 4.2, 11.5, 6.8, 5.2, 5.4, 6.3, 12.1, 11.5, 11.9, 7.8, 13.1, 5.8, and 6.2. So part A, we need to find the mean of this data set. I am not going to rewrite them all in order to just add them all up. I don't know why that needed to disappear. It's giving me trouble. I don't want you to give me trouble. Please just go down here. Thank you. Okay, so we add up our data points to find our mean. So this is something that is really easy to make mistakes on. I make mistakes on adding my data points up all the time, which is frustrating. So you want to be slow and deliberate, just very conscious of your details, because the more data points you have, the easier it is to make mistakes. And calculators don't catch your mistakes. They just do what it is that you tell them to do. $6.2. Okay, so adding them all up, we get 107.8. And then we need to divide by, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 points. So we divide by 13 to find the mean. is equal to 8.3. So the mean of this data is 8.3. Then the median for the above data. So now we need to arrange our data in order from smallest to biggest in order to find the middle point. So 4.2 is my smallest. And I just go through and I find the next smallest. Okay, so I have 5.2. Looks to me like 5.2 is my next point. Then after 5.2, well, I have a 5.4. And then I have a 5.8. And then I have a 6.2 and 6.3. And then a 6.8. So I don't want to write it out when I'm adding them because I have to write it out to organize them. 6.8, then 7.8. And then after 7.8, it looks like 11.5. And I have two 11.5s. And then 11.9, 12.1, and 13.1. Okay, so now I've ordered my data from lowest to highest. So and now what I'm going to do is I'm going to cross off my lowest, cross off my highest, and I just keep doing that lowest to highest to figure out what my middle term is. So my median is 6.8 because that is my middle data set value. Then the mode for our data set, well, we're going to, you don't have to order your data, but ordering your data helps you collect it. So it helps you find out what you have more than one of. And so 11.5 is what our mode is because we have two values of 11.5. So you can see our mean, median, mode are really quite different about this data set. And so that really is going to deciding which one is the best one to use, depending on your situation, is really going to be quite different. All right, number 2. Now this is part D. We are now going to find the measures of variability for this data set. So part D, find the range for the above data set. So our highest value was 13.1. Our lowest value is 4.2. So we are going to subtract those. 13.1, take away 4.2. So our range is 8.9. Then part E, we need to find the variance for the above data set. So the variance is this chart that I have over here, helps us. So I don't think I have. Having something that's organized is really useful. So I'm just going back to find the mean, which is 8.3. So 8.3 is our mean for the whole data set. You can write it down. You don't have to write it down. Then we need to find the difference between the mean for each of these values. So I'm going to get my calculator out. So again, this is time consuming, which is why I like to have it in a chart to help me keep it organized. I'm going to do this a little bit different than I usually do. Usually I do the whole difference of the mean in one step and then do the squared. This time I'm going to just square my answers after I find them so that I don't have to retype them in. So 3.2 is my difference. and that's 10.24. 6.8 take away 8.3 is equal to negative 1.5, which I'm going to square. 5.2 take away 8.3 is equal to negative 3.1, which I'm going to square, which is 9.61. 5.4 take away 8.3 is equal to negative 2.9. Square that is 8.41. 6.3 take away 8.3 is negative 2. Negative 2 squared is 4. 12.1 take away 8.3 is 3.8. So again, this is tedious, but having a chart really helps to keep yourself organized. You don't have to do it this way. You can do it a different way. If that works for you, that's fine. But this is what works for me. If you just wanted to write it all out and put it all in your calculator at the same time, you could do that. Again, you just want to be careful that whatever it is that you choose to do, you're being true to the data collection. So you're not like, you can't just add them all up and then take away 8.3 13 times, because we need to square each individual data point. So basically, accepting the fact that this is tedious and takes a while is your best bet. Statistics was never my favorite part of math when I was studying it. But some people love it. But also, I actually like math, and many people don't think I'm crazy. So, you know, almost done. 5.8 take away 8.3 equals negative 2.5 squared, 6.25. 6.2 take away 8.3 is equal to negative 2.1 squared is equal to 4.41. Okay, so we figured out the difference between the mean. We've squared each of those differences, and now we need to add those differences up. So now I'm just going to add my third column up, making sure I put my decimal places in, because again, really easy to slip up and make a mistake, and then hard to catch it and find where you made your mistake. So just be careful. This is really good practicing for attention to detail skills, which are really important skills in lots of different parts of your life. But doing this way, I'm enjoying just having to add them up and now and not having to square them. And 4.41 is my last one. So that is 122.91. And then we divide that by 13, take away 1. So divided by 13, take away 1, it's just 12. We get 10.24. So our variance is 10.24. Again, that doesn't really help me. I don't understand it, but to find our standard deviation, we take the square root of 10.24, which gives us 3.2. So plus or minus technically 3.2. So what that means is that all of our data, a lot of our data is either within the range of 3.2 above our mean or 3.2 below our mean, is what the standard deviation tells us. So yes, the variance is a pain. The standard deviation feels useful and is pretty easy to do once you have your variance. Okay, lesson 18, looking at data distributions. So here we looked at histograms, which is like a bar graph, but either bars are touching because your data is continuous. It means that there's no gaps in your data. It shows the data frequency in intervals. Then we looked at how to analyze this data. So a normal distribution is symmetrical around your mean. So your mean, median, mode is all the same, your highest point, and then your information falls both in terms of higher and lower in sort of a symmetrical pattern. A bimodal distribution is that you have two peaks or two modes. It either can be symmetrical where you have two peaks that are exactly the same, or it could be, you could have one peak that is lower, but still information is clustered around it. A left skew distribution is when you have your mean is less than your median, which is less than your mode. And so you have less information on the left side and your peak is on your right side. So your information is pushed away from the left, which is why it's called left skewed. My brain wants to get these backwards. So just be really careful and figure out how to make it make sense for yourself. Right skew distribution is when your mean is greater than your median, which is greater than your mode. So your information is, your peak information, your more information is clustered on your left. And you have your tail is on the right. So all your information is pushed away from your right. Okay, so let's look at some information about this. So number 3, the winning Super Bowl scores from 2000 to 2022 are listed below. I'm not going to read them all out, but there's 22 years of scores there. We're going to create a frequency table of this data in order to then create a frequency chart or histogram. So our scores we're going to put in intervals. We're going to look and see, okay, our scores range from the lowest one the first one I see is 20. I'm going to see if there's a lower value. Oh, no, I see a lower value of 13. So I'm going to say that 10, I'm going to do an interval of 10. I'm going to do it in groups of 5. So 10, 11, 12, 13, 14 is my first interval. So then 15 to not 29, 19. Then 20 to 24, then 25 to 29, then 30 to 34, then 35 to 39, then 40 to 44, and 45 to 49. And then I'm just going to quickly look to make sure that I don't have any data that is greater than that. It doesn't look like it. So it looks like that is going to work for my intervals. So then I'm going to tally. I'm going to go through and I'm just going to tally this up. And I don't have to go by the order of my intervals. I can go by the order of my data. So 23 I see is in 20 to 24. I cross it off. 24 is also there. 20 is also there. 48 is down here. 32 is here. Another 24. 21. Now I've got 5 there, so I'm going to cross it over with my tally mark. 29 is here. 17 is here. 27 is here. 31 is here. Another 31 is here. 21 is here. 34. So just going through and we're organizing our data into intervals so that we can then analyze it. 34, so another 5, 41, 13, 31, another 31, and 23. Okay, so we have our tally marks, and now we're going to just list the frequency so that we know how many we have. So our first interval, we have 1, second interval, we have 1, third, we have 8, then 3, then 7, then 0, then 2, then 1. Okay, so now we've created a frequency table. We know we've clustered in our information. Now we need to create a histogram of this data. So our intervals, remember, we started with 10. And then we can just put 15 because our data is continuous. There's nothing between 14 and 15. We can just count up by 5s. So 10, 20, 25, 30, 35, 40, 45, 50. And then so that is our scores. And then our frequency was 0, 1, 2, 3, 4, 5, 6, 7, 8. Now, I'm just doing this freehand. You should be using a ruler and making sure that your distances are actually accurate, but this is the best we can do on a smart board. Now we need to know what our intervals were. So I remember our first one was 1. Our second one was also 1. Then I went 8, 3, 7. So from 20 to 25 was 8. And then 3. And then 7. And then it was 0. And then 2. And then 1, I believe. Or was it 1, 2? No, 2, 1. Okay, so this is Super Bowl scores. We want to give a title 2000 to 2022 so that we know what it is that we're talking about. And so that the people who are reading our data know what it is that we're talking about. So that is what our histogram looks like. Obviously, mine is not beautiful because I did it freehand. Using a ruler is what you need to do, or some sort of graphing data, like technology. So part C, identify the type of distribution. So to me, it's not the reality is that those diagrams that I showed you for the type of distributions were like very stepwise and like pretty and really clear. That's not how real data is. So here I would say, looks like I go up and then I go down. I would say that this is probably, my information is to the peaked at the left. So I would say that it's right skewed. If we did our intervals differently, it might look a little bit differently, but in theory, it should be similar. We still should have clusters around these same parts. It would just be broken up a little bit differently. So again, you can justify, if you can justify it, I might be willing to take a different answer, but you won't need to justify it for me. Lesson 19, theoretical probability. So some terminology for theoretical probability is that we had to make sure that we knew what probability, successful result, trials, sample space, outcome, and event all meant. With theoretical probability, this is what we, in theory, is going to work out. Experimental probability, remember, is if we do an experiment and we try it out. Theoretical is if we were to do that experiment like 1 million times, what results would we probably get? So theoretical probability is found by doing the number of desired outcomes. Remember, desired does not necessarily mean positive. It's just what you're looking for. So maybe you're looking for the number of times car accidents. That is your desired outcome, even though car accidents are not a positive thing. Divided by the total number of possible outcomes. We use tree diagrams to help us organize information. So this displays all the events by using one branch for each possible outcome. We also include the probability of that outcome happening on our tree diagram. So here's an example of flipping corn twice. So on the first flip, we either get heads or tails. And then our second flip, we still either get heads and tails, but either we had heads last time or we had tails last time. So that changes our overall probability. And then we talked about calculating probability. So when we're determining the probability of multiple events, then we need to multiply the probabilities of each individual event to see how both of them happening, the chance of both of them happening is. All right, number 4 in our practice questions. When drawing from a deck of cards, what is the probability of drawing a face card, then an even number card? You replace the card after drawing the face card. Write your answer as a percent rounded to 1 decimal. So remember, with decks of cards, we have a total of 52 cards. Then there, for the face cards, so the ones with faces, those are the kings, queens, and jacks. So there are 3 face cards per suit, and there are 4 suits in a deck. So that means that there's 3 times 4, which is 12. So there's 12 face cards in a deck of cards. And then how many even? So then the number of even cards. So the even cards are 2, 4, 6, 8, 10. So there's 5 even cards again per suit. So there's 4 suits. So 5 times 4 is 20. So just to know the number of cards that are possibilities. So then to find the probability of getting a face card and then getting an even card is what we're trying to figure out. So that means we have to do the probability of finding a face card times the probability of getting an even card. So the probability of finding a face card, picking a face card, is 12 out of 52. And the probability of getting an even card is 20 out of 52. Now, I know that these both can simplify to, so this can be 3 out of 13 times 4 out of 13. And then to multiply this, we're going to get 12. 13 times 13 is 169. You can totally do that on your calculator. You don't have to do that in your head. I just knew it. And then, but it asked not for it to be in a fraction. It said, write your answer as a percent rounded to 1 decimal place. So let's check to make sure that I did get it right. So 3 divided, no, let's go from the beginning. 12 divided by 52 times 20 divided by 52 is equal to 0.088. So then times that by 100, answer in, we get 8.9%. So the probability of the probability of drawing first a face card and then an even card is 8.9%. Okay, number 5. You and your friend Floyd are driving to Montreal to see a concert. You decide to flip a coin 3 times to decide who will pay for gas. Floyd says he will pay if the coin lands on 3 of a kind, either 3 heads or 3 tails, and you can pay otherwise. Part A, use a tree diagram to display all the possible results of flipping a coin 3 times. So remember how we draw a tree diagram is that we draw a branch for each option. So for flip 1, we have heads or tails. We can just put H and T. We don't have to write the whole word out. For flip 2, we again have heads and tails for each of these branches. And then for flip 3, As you can see, it's really easy you get really squished really quickly. We have heads or tails for each option. Only doing 2 options, so think if we had more options, it would be even more squished. Okay, so we've used a tree diagram to display all the possible results of flipping a coin 3 times. So I'm just going to list my results at the end. You don't have to do this, but here I have heads, heads, heads. My second option is heads, heads, tails. Then I have heads, tails, heads. Then I have heads, tails, tails. Then I have tails, heads, heads, tails, heads, tails, 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 heads, or tails, tails, tails. So sometimes listing your results just helps you analyze your information a little bit. So express as a percentage the probability of getting 2 heads. So now with our results, we know that we have 1, 2, 3, 4, 5, 6, 7, 8. We have a total of 8 different possibilities, outcomes. And we said 2 heads. So we have 1, 2, 3 ways that we get 2 heads. So we get 3 out of 8, which is, this one I always do wrong. 3 divided by 8 is 0.375. So as a percentage, that's going to be 37.5%. Then getting at least 2 tails. So getting at least 2 tails. Which one? So here, at least 2 tails means that we have 2 or 3 tails. So this one, this one, this one, or this one. So we have 4 options. So we have 4 out of 8, which is 50%. 3 of a kind. Well, 3 of a kind is either heads, 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 or tails, tails, tails. So we only have 2 options there. That's 25%. So part C is this a fair way to decide who will pay for gas? Explain. So Floyd has said he will pay for gas 25%. The chances of him paying for gas is 25%. That means the chances of you paying for gas is 75%. So this is not fair. All right, and our last lesson, probability and statistics in the media, lesson 20. So statistics can be a really powerful way of communicating information. They can make things clearer and more accessible to understand, but they can also be really misleading. It's really easy to skew information or only present part of a story. It's essential to think critically about the information presented to us by the media. We can't assume that they're giving us all the information. So for number 6, arts question, many people jump to conclusions after reading headlines. The 2 below headlines are based on the same set of data from Global Web Index research report in social media trends over the last year. What do you notice? One headline A says 98% of digital consumers are social media users. And headline B says almost half of Brits have reduced time spent on social media. So headline A tells me 98% of digital consumers are social media consumers. This makes me think lots of people use social media. Maybe this is a problem. That's what it makes me think of. It's almost 100% of people, but it's 100% of digital consumers. Okay. And then headline B says almost half of Brits have reduced time spent on social media. So people are using social media less. So it's still both can be true that lots of people use social media, but people are using social media less. So just because they use it doesn't mean they use it as much. So these two things sort of contradict each other if you're not thinking about, again, that whole picture. So then part B, is it true that the majority of digital consumers are social media users? But when looking at the actual data, what do you notice? So here now we're looking at the data and we can see that by age group, it's really different. So 16 to 24-year-olds generally use 3 hours or on social media 3 hours a day. As you get older, there are less people are using it. And over time, we can see that there is an increase in the amount of usage overall. So that's just really different, gives us different information, the headlines compared to the actual data. So again, we need to be really careful about how we consume media. Then this part C, how does the information below contradict the former graph? What information is missing? 41% of Brits say they've decreased time spent on social networks over the last 12 months compared to 46% of Americans. Many have also deactivated their accounts. So just there's not a whole piece of information. So it's really important to be careful with that. All right, and that ends our review. Remember that if you have any questions, please reach out and connect with me. All of our information is up on our playlist, MBF3C, on my YouTube channel, Wahsa. You can give me a call at the office at 807-737-1488, extension 2209 to ask me questions, or also toll free 1-800-667-3703. Send me an email at broadwin.slate@nnec.on.ca or connect with me through Facebook at Wahsa. I'm here to help you however I can to prepare for your culminating activity and also to help you get through all of your units. Thank you so much for joining me today. Good luck with your review and miigwech.